Introducing the 2022-2 Schrödinger release. Let's take a brief look at some of the new features and enhancements. Starting in Maestro, we see a new preference to improve graphics performance by employing depth peeling on GPUs. This option is still in beta, but if enabled, GPU accelerated rendering on transparent objects, such as transparent surfaces, should be significantly faster and feel smoother for larger systems. Also, when enabled, a new option will appear in the Style toolbox that allows rendering of transparent secondary structure cartoons and ribbons. The transparency can be applied to all ribbons or only on selected atoms. Elsewhere in Maestro, we see an updated presets menu, which includes a new item, Binding Pose Comparison. This preset is ideal for reviewing binding poses from induced fit docking and IFDMD, as each complex is conveniently colored by entry. Over in the project table, a new menu is available to select first entries per title. As an example, after sorting and ranking entries, one can choose top scorers by selecting the first entry per title and thus deselecting the duplicates. This can be done across all entries in the project, or limited to a selection, or only across independent groups, or within their subgroups. And in the structure hierarchy, there are now additional controls for switching on or off the annotated features for antibodies, as well as applying different antibody annotations. And speaking of antibodies, among the Applications and Tasks panels, we have a new Antibody Structure Prediction panel with improved antibody detection, alignment, and framework search protocols. The interface accommodates non-traditional antibody formats such as bispecifics, and now supports high-throughput workflows, where one can specify a table of heavy and light chain sequences for batch antibody homology modeling. Over in the IFDMD panel, we see an improved design that allows for a broader range of targets and ligands. It now supports covalent docking, and it uses a familiar setup to the covalent docking panel, where one can specify the reactive residue and the corresponding reaction type, and also specify the reaction site on the ligand, which is nicely depicted in the 2D image. And the panel now also supports membrane-bound proteins, where one can optionally include an explicit membrane to the workflow. In the various FEP Plus panels, we see a new advanced option to add sodium chloride salt. This can be useful in some systems that require additional salt, such as DNA and RNA systems. And now users can analyze results of solubility FEP simulations using the full-featured perturbation report panel. In the Jaguar QM panels, we see the support of analytic or pseudospectral RIMP2 energies, gradients, and second derivatives. The corresponding basis sets are conveniently organized in a new RIMP2 compatible filter. In the Ligand Designer, we now have finer control over ligand growth space selection, making it easier to select complete growth space regions of the pocket. In the Multiple Sequence Viewer and Editor, one can easily zoom to selected branches in the dendrogram. Over in pharmacophore modeling, users can now optionally hide hypothesis feature labels. And finally, this release introduces a new simple panel for computing some 160 protein-specific descriptors based on sequence, structure, and surface features, which can be used in liability predictions. This is just an overview of the 2022-2 Schrödinger release. As always, for the complete list and to learn more, visit schrodinger.com/new features.